Imagine being caught between the two most destructive forces in the universe. A black hole that devours light itself versus a neutron star spinning 700 times per second with the power to shred atoms. Today, we're settling the ultimate cosmic deathmatch. Which one destroys you first? In the cosmic arena, two champions of destruction stand unmatched, the black hole and the neutron star. The black hole is a region of space-time so warped that nothing, not even light, can escape. The neutron star is a city-sized sphere of matter, so dense a teaspoon would outweigh humanity. Imagine you're a space traveler, forced to choose veer toward a black hole or a neutron star. Both spell doom, but the journey is profoundly different. Which cosmic monster destroys you faster? Which tears you apart from farther away? This is a story of gravity, magnetism, and the raw power of the universe. The black hole is a master of gravity. The neutron star, a brute of magnetism and radiation. Our journey will reveal how each annihilates anything that dares approach. So buckle up, the universe is waiting. Time to choose your destroyer. Hey cosmic explorers, I'm Mallory, and welcome back to Mallory Inspires, where we dive deep into the universe's greatest mysteries. If this cosmic battle sounds incredible to you, smash that like button right now. It tells YouTube to show this to more space lovers like yourself. Today we're analyzing two cosmic titans in a battle that could literally tear reality apart. By the end, you'll know exactly which one would end you faster and why. Let's meet our first contender. Let's start with the black hole, the celebrity of cosmic calamities. Its weapon is gravity, unleashed to extremes. As you approach, tidal forces stretch you. Spaghettification begins. Your body and ship are pulled into a glowing ribbon of atoms, spiraling toward the event horizon. The event horizon is the point of no return. Beyond it, escape is impossible. All paths lead to the singularity, a point where physics breaks down. But before you even reach the event horizon, danger lurks. Many black holes feed on nearby matter, forming a superheated accretion disk. This disk blazes with X-rays, vaporizing anything that comes close. So, the black hole kills with both gravity and radiation. It's a patient, methodical destroyer. Cross the event horizon and your fate is sealed. The black hole's destruction is silent, final, and absolute. Not all black holes destroy the same way their size matters. Stellar mass black holes, a few times the sun's mass, have steep gravitational gradients. They spaghettify you before you even reach the event horizon, a dramatic, visible end. Supermassive black holes, millions or billions of solar masses, are gentler at the edge. Their event horizons are vast, so you could cross intact, feeling little at first. But inside, the pull is absolute. Spaghettification comes later, hidden from the universe. So, a stellar mass black hole offers a violent public demise. A supermassive black hole gives you a quiet, secret passage into oblivion. Both end at the singularity, where physics ceases to exist. The manner of your death depends on your choice of black hole. The universe offers options, even in destruction. Choose your executioner wisely. Now meet the neutron star, the universe's berserker born from a supernova. It packs the sun's mass into a city-sized sphere. Its gravity is immense, but its true terror lies in its spin and magnetic field. Many neutron stars spin hundreds of times per second, generating magnetic fields trillions of times stronger than Earth's. These are pulsars, sweeping beams of deadly radiation across space. A single beam could sterilize planets from light years away. The neutron star can kill from a distance long before gravity becomes a threat. Its radiation is lethal, its magnetism overwhelming. Approaching one is like entering a nuclear reactor and particle accelerator combined. Matter itself struggles to exist near a neutron star. It's a tiny tyrant punching far above its weight. The neutron star's magnetic field is its most terrifying weapon. Magnetars, the most extreme neutron stars, have fields that distort and destroy matter at the atomic level. Electronics are fried from millions of kilometers away. At close range, your atoms are stretched and bonds broken. Chemistry itself unravels. You're not spaghettified by gravity, but disassembled by magnetism. This magnetic apocalypse can kill from over 1,000 kilometers away. The black hole needs you close. The magnetar kills from afar. The neutron star's destruction is electromagnetic and fundamental. It erases you at the level of atoms, rewriting the rules of matter. Before you sense danger, you're already gone. This is annihilation on a whole new level. Let's compare our astronaut's fate at 3 distances from each cosmic titan. At 10,000 kilometers near the black hole, your safe tidal forces are weak. Near the neutron star, you're already dead from radiation and magnetism. At 1,000 kilometers, the black hole's tidal forces become deadly spaghettification looms. The neutron star's magnetic field rips your ship apart at the molecular level. At 100 kilometers, the black hole finishes you atoms stretched and spiraling in. Near the neutron star, nothing remains, you were vaporized long ago. The neutron star's sphere of destruction is larger and more versatile. It kills sooner with more tools, radiation, magnetism, gravity. The black hole is lethal up close, the neutron star is lethal from afar. The neutron star's reach is unmatched. Its kill zone extends far beyond the black hole's. In this cosmic duel, versatility and range matter. The neutron star dominates at every distance. The black hole is a specialist, the neutron star, a universal threat. The verdict is becoming clear. The verdict is in the neutron star is the faster, deadlier destroyer. The black hole's gravity is lethal, but only up close. The neutron star attacks with radiation and magnetism from vast distances. Its lethal dose of radiation can reach millions of kilometers. Its magnetic field can tear apart atoms thousands of kilometers away. The black hole's spaghettification zone is tiny by comparison. The neutron star's kill radius is immense. If you must choose your doom, the black hole offers a slow, gravitational end. The neutron star delivers a quick, violent demise. In the cosmic showdown, the neutron star takes the crown. The universe's tiny tyrant is the ultimate destroyer. But what if these titans collide? When a black hole and neutron star merge, the result is a kilonova, a cosmic cataclysm. The black hole's gravity tears apart the neutron star, forming a hot accretion disk. Neutron-rich material is ejected, forging heavy elements like gold and platinum. These collisions seed the cosmos with the building blocks of planets and life. The merger sends gravitational waves rippling across the universe. In 2017, we detected these waves, feeling the universe's vibrations for the first time. It opened a new window into the most extreme events in the cosmos. The clash of these titans echoes across billions of light years, telling the story of creation and destruction. So there you have it, cosmic explorers. Neutron stars take the crown as the universe's ultimate destroyer. But I'm curious, which one did you think would win before we dove into the science? Were you team black hole or team neutron star from the start? Drop a comment below and let me know your thoughts. Did any of these cosmic destruction facts surprise you? And if you're fascinated by these extreme cosmic phenomena like I am, make sure to subscribe and hit that notification bell. We've got so many more mind-bending space mysteries to explore together. Until next time, keep looking up and stay curious about our incredible universe. This is Mallory, and I'll see you in the next cosmic adventure. Copyright 2025 Mallory Hope Carrington trademark, all rights reserved.